So now that we have looked at the different elements of a quadratic function, we've looked at what they would look like if we were given a graph, what they would look like if they were given an equation. We want to now put the two together. So go from an equation, find all of the elements, and then create the graph of that quadratic. Okay, so we've listed out some steps here, but pretty much what we're going to do is we're going to find all the elements that we did before, and then we're going to go plot those points using that axis of symmetry to verify that it reflects, right? So let's look at our first example. We're going to do one in vertex form and one in standard form. So the first thing that we want to do is we want to determine, is it going to open up, open down? Is it going to have a maximum or minimum? So remember, we're going to do that by looking at the A. In this case, our A is negative, so this means it's going to open down, which is going to cause it to have a maximum value. Okay. So then the next question is, okay, well, what is that value? What is the point that the vertex is? Okay. So now to find the vertex of this equation, the vertex is going to be how we are moving to the right 1, and that we were moving up 8, which means our vertex would be 1, 8. From that vertex, we can get the axis of symmetry very quickly because we know that it's just the x value of the vertex, right? So now what we want to do is we want to find the intercepts so that we can go put them on the x-axis. So to find the x-intercepts, remember what we want to do is we want to set the equation equal to 0 so that we can go solve it. So now solving this, I'm going to subtract that 8. Then I'm going to divide by that -2. Then I'm going to take the square root. Remember, when I take the square root, I get a positive and a negative. So I'm going to get +2 is equal to x minus 1, and -2 is equal to x minus 1. Solve each of those. So I'm going to get 3 as a solution, and -1 as a solution. So what that means is that my x-intercepts are going to be 3, 0, and -1, 0. Okay. So now I can go put all of these values on my graph. I can also go ahead and find the y-intercept. Remember, I can find the y-intercept by plugging in 0 for the x. So I can do that quickly here. All right, so I'm going to take 0 minus 1 is -1. Squaring it gives me 1. 1 times -2 gives me -2 plus 8. So my y-intercept is going to be here at 6. So out of the point 0, 6. So now what I want to do is I'm going to put everything that I have onto my graph and see what I have. Okay, so I'm going to put my vertex 1, 8 on the graph. I'm going to put my intercepts, which is 3, 0, and -1, 0. I'm going to put my intercept, my y-intercept, 0, 6. Okay, so now when I do this, remembering that my axis of symmetry is going to go right down the center of that vertex. So even though I'm just going to put a little dashed line here because it's not really part of my graph, but I know that it's going to reflect over. So I can see that my x-intercepts reflect over. If I want to find what the reflection of this y-intercept is, I can tell, well, it's 1 away, so here would be my reflected over that axis of symmetry line. So now all I need to do is connect the dots, and I've got my quadratic equation. Okay, so now I've got my quadratic function graphed just by being able to determine all of its characteristics and graph that function. We're going to do the same thing, but now our equation is going to be in standard form. So we're going to start off the same. I'm going to look at my A term. My A term is positive, so that means it's going to open up this time, which means it's going to have a minimum value. So then the question is, well, where is that value? What is the vertex? So remember, with this vertex, we're going to have to use our formula. We're going to take opposite of B, which is -6, over 2 times my A. So I'm going to get -3. I take that number and I go plug it back in to get what the Y value is. So I get -4. So my vertex is going to be -3, -4. Which means that my axis of symmetry is going to be x equals -3. And notice that an axis of symmetry is an x equals because it's a vertical line. So don't just put -3. We want to say x equals -3. All right, so now we're going to go to our x-intercepts. X-intercepts, I'm going to set it equal to 0. Now, instead of using my square root property, I can either quadratic formula or I can factor. I'm going to go ahead and factor this one because I know that the factors are going to be 5 and 1. Remember, to solve, I'm going to set each of those factors equal to 0. Finish solving means I'm going to subtract that 5, so x is going to equal -5. Subtract my 1, so x is going to equal -1. So my x-intercepts are going to be -5, 0, and -1, 0. All right, last thing, I can find my y-intercept. My y-intercept, I'm going to take y equals, I'm going to plug in a 0 for all of my x's. So I can see that my y-intercept is going to be at 5. So it would have 0, 5. Now I'm going to go to my graph and I'm going to plot all of that. So I'm going to go to -3, -4. Put my dot. Then I'm going to go to my x-intercepts, which are -5 on the x-axis and -1 on the x-axis. I'm going to go to my y-intercept is at 5 on the y-axis. I'm going to plot a little bit of that axis of symmetry so that I can see where this reflected y-intercept is going to end up. So 1, 2, 3. So all I'm doing is I'm counting from the y-intercept to that axis of symmetry, and then I'm going to reflect it over on the other side. So I'm going to count to the line and then count away from the line. So I notice I'm a distance of 3 away from the line, so I'm going to go 3 away from the line in the other direction. That's how I reflect. So now I can connect those dots, and we've got the graph of that quadratic function. All right, so now we should be able to find all of the elements and plot the points and make the graph from an equation.